Hello, calculus students. A couple of you were absent today, so here is a recording of the material that we went over today in class. The students that were in attendance made it pretty clear that the product and quotient rules is something that y'all had covered previously. So we're going to take a very brief look at the rules and how they function within a couple of examples. And if you need more help than that, please just make arrangements to come in before or after school for tutorial times. Okay, our objective for the day is to learn and implement rules for differentiating functions by the product and quotient rules. Student will demonstrate the ability to apply the new rules of differentiation to provided functions. And your essential question for the day is, do I recognize when and where to apply the new formulas, and do I know how to apply them? Okay, so we've already seen sum and difference rules, and we learned that those are really not all that complicated. However, products and quotients, not nearly as simple. Okay, now the product rule basically states if you need to take the derivative with respect to x of two functions, f of x and g of x in this case, okay, if we need to take the derivative of those two functions and they are being multiplied by each other. The rule says what we're going to do is a procedure basically by which we are going to take one function times the derivative of the other and add that to the other function times the derivative of the first. Okay, so f and g, f of x times the derivative of g, and add that to g of x times the derivative of f. Further, this process can be expanded to larger products if we ever had the need to do that. So let's say we had three functions being multiplied times each other and we needed to take the derivative of that product. Then it works basically the same way. As you can see in each of the terms that are part of the sum, one of the functions has its derivative being taken, and then that derivative is multiplying by the other functions as they are. So f of x, or the derivative of f times g times h, add that to derivative of g times f times h, and add that to the derivative of h times f times g. And that can be expanded as far as we need it to. However, we don't typically run into the product rule in more than two functions being multiplied together. Okay, so for example, we took a brief look at this. Find the derivative of h of x, where h of x is defined as 3x minus 2x squared times 5 plus 4x. Okay. By the derivative rule for products, we're going to take the derivative of one function, multiply it times the other function, and then reverse that for the second term. So what I've done here is I have taken the first function, 3x minus 2x squared, left it alone. Then we'll perform the derivative of the second function, 5 plus 4x. We'll add that to the second function, 5 plus 4x, multiply it times the derivative of the first function, 3x minus 2x squared. Okay, so focusing on the derivatives for the next step, the derivative of 5 plus 4x is 4, and the derivative of 3x minus 2x squared is 3 minus 4x. Now, as you can see, this is down to basic algebra. We're going to, please excuse my dear Aunt Sally right there, use your distributive rules to multiply those polynomials together. The 4 distributes in, becomes 12x minus 8x squared, and in the binomial times the binomial on the right side, okay, everything on the left times everything on the right, we end up with a 15, a negative 20x to the first, a positive 12x to the first, and a negative 16x squared. You have like terms there that can be combined all over the places. We have negative 8x squareds and then negative 16x squareds. That's negative 24 of them. We have 12x's minus 20x's plus 12 more x's. My mental math tells me that should be 44 of them. And then we have 15 constants. Okay, so there's that. Oops, sorry, missed my sign on the x to the first. Okay, negative 20, and 12 and 12 is positive 4. Okay, so here is another example. I'm just going to go ahead and uncover it all. And if you need a little bit of practice time on it, you can press pause on the video and take a look at the step-by-step for yourself right there. Okay, the quotient rule, not quite as friendly of a formula, and here's what it states. We have the derivative with respect to x of two functions in terms of x that are being divided by each other, f of x and g of x. Please pay close attention to the positioning of f of x and g of x, which one is in the numerator and which one is in the denominator, because you will absolutely mess this problem up if you don't get your numerator and denominator correct. The definition says you're going to take the denominator, function in the denominator, and multiply it times the derivative of the numerator's function. From that, you subtract the numerator's function times the derivative of the denominator's function, and that is all over the denominator's function squared. Okay, so we're going to have a little bit of information to keep track of as we go through this formula. Okay, so let's have a look at an example. Find the derivative with respect to x of 5x minus 2 over x squared plus 1. Okay, following the formula, we want the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Okay, so just plugging in, making it look basically like we just did a moment ago with the product rule, just making sure we get the signs correct because it's the quotient rule instead. Now in the denominator, you notice all I did was just take the denominator and put a square exponent on it. We're not going to expand that guy. Typically expanding the denominator does not lead you to anything fruitful. So it's just kind of easier just to leave that guy in exponential notation rather than expanding it. Okay, so we need to take our derivatives in the numerator. The derivative of 5x minus 2 is, of course, 5. And on the right, the derivative of x squared plus 1 is 2x. Okay, so just simplifying, now doing your distributive property there. Okay, we end up with those guys. You have like terms. 5x squareds minus 10x squareds is negative 5 of them. We have a double negative 4x, so we're going to have positive 4x's, and then we have positive 5 constants. So there it is, it's simplified, and you're done. The only other thing we really took some time to do in class was to look at the beginning of this example and basically to state that anytime you run into complex fractions, it's to your benefit to eliminate the complex fractions as soon as possible before you begin really working on the problem. So what I would do here is I would focus on the numerator and get a common denominator for the numerator, see if I can condense that into a monomial rather than a binomial, and then possibly simplify. Okay, so finding a common denominator, which would be an x, we're able to simplify it into a single fraction, then leaf change flip, and we end up with, looks like I've got a slide out of place or something there. But anyway, we end up in this step right here, okay, with a single fraction, and then there's really no reason to have the x on the outside of the parentheses there, so redistributing it inside, and then you would begin to go through your quotient rule to find the derivative. And I'll show you the slide. You can look through the steps one at a time. Go ahead and press pause if you need to and examine the steps, and you'll see how the quotient rule unfolds. Okay, that's basically all we did in class. The assignment is on page 125, numbers 1 through 4 and 7 through 10. And drop by the classroom if anything about that is unclear.